Welcome back to Digital Switching System virtual class. Today we will be discussing switching system software. Till now we are discussing the hardware aspects of digital switching system. So from now onwards we will start understanding the software aspects of digital switching system. Clearly, a modern digital switching system is quite complex. At this stage of digital switching evolution, most of the complexity comes from the software, which is much more complex and harder to manage than the hardware it controls. In the early part of the evolution, in the late 1970s, 1980s, the hardware was more difficult to handle. But today, with the evolution of software taking control of most part of the system, the complexity of the software is much more complex compared to the hardware aspects which it is controlling. So we are going to understand the software aspects which controls a digital switching system for few more classes in this module. Now let us understand the basic software architecture of any digital switching system. Most of today's digital switching systems employ quasi-distributed hardware and software architecture. This module elaborates on the software employed in the digital switching system at different levels of control. You can see the figure, it shows the basic software architecture of a digital switching system where different levels of control along with some details of minimum software architectural functions that may be necessary for each level of control is shown. And you can see that there are three different levels of control: level 1, level 2, level 3, and each of them we are going to discuss in this class. So before we move to the level 1, level 2, level 3, let us understand what kind of operating system, what kind of kernel needs to be there for the proper functioning of digital switching system. So this figure is the basic software architecture of a digital switching system. Now let us discuss about the operating system used in digital switching system. As you have studied a subject called operating system, you are already familiar with the concept. So this is just a refresher for those concepts which you have learnt in operating system and how those can be used for a typical digital switching system. As you know that every digital switching system has an operating system as a part of its software architecture. Any operating system may be defined as software that manages the resources of a computer system or controls and tasks other programs. This you are already familiar with. Sometimes these programs may be referred to as control programs, supervisory programs, executive programs, or monitor programs. So this is just giving you the definition of an operating system in general. And the same holds good for digital switching system. And from the figure, you can see that at every level, there is an operating system which is being used to control the different operations. The operating systems employed by digital switching system are real-time operating systems. So now we are coming in to the operating system which is used for digital switching system. Those operating systems are real-time operating system, RTOS. There is a subject called RTOS in your higher semester which you will be learning in detail. So this type of operating system is required for digital switching system since the very nature of telephone processing demands execution of tasks in real time. Because we do transactions in real time, just like telephone phone connection where we are talking in real time, we require an operating system which can operate in real time. That is why the operating system used is RTOS, or real-time operating system. Typically, the real-time operating system for the digital switching system interacts with different layers of applications necessary to support telephony features and functions. Since practically all modern digital switching systems use quasi-distributed architecture, that means the architectures are distributed, it's not at one level. The processor or controller for each subsystem may even use different operating systems than the central processor does. And that is what is shown in this figure. Every level can have different operating systems. Each subsystem may employ a different type of processor and therefore may employ different high-level languages for the development of its software. So the advantage of this level of level division, you can have different processor at each level, and you can have different operating system, and you can use different high-level language for the development of the software. So what is the conclusion? The operating system which is used in the digital switching system is real-time operating system, and at every level you can have different operating systems that can control the different functions. Now let us discuss the heart of any operating system, kernel. The kernel, or the nucleus of any operating system, comprises those functions of an operating system that are most primitive to the environment. It usually supports the following functions. What are the functions it supports? Those are: the first one, process control and scheduling. Second, main memory management. Input-output control of requests for terminals and buffers. Domain protection of main memory, read or write operations, and etc. You have already studied these concepts in your operating system, so these are not new concepts for you. So you already know this, but we are just refreshing it from the digital system switching system perspective. So now from digital switching system perspective, what kind of operations are performed by the kernel? Most of the real-time operating systems that control digital switching system use priority interrupt systems. So they use priority interrupt system. So what do you think will be the highest priority uh, should be given by the kernel for a digital switching system? Yes, you are right. The highest priority should be given for system maintenance. Then the priority should be given for call processing and other ancillary functions. That is how the priority has to be assigned. These interrupts are serviced by the kernel based on the importance of the operation, and that is what we were discussing. Most digital switching systems employ kernels that reside in the main memory. Now let us discuss about database management. As you know, in any digital switching system, we need to store a lot of information about the subscribers and the routing informations. So where or what kind of database management does a software uses in a digital switching system, that we are going to discuss now. The databases that are employed in digital switching systems are usually relational and sometimes distributed. So there are two kinds. One is relational database, or sometimes it is distributed databases. So in simple terms, distributed database imply multiple databases that require data synchronization. So distributed databases are multiple databases which requires a synchronization. Those kind of databases are distributed. Now what are relational databases? The relational database systems use the relational data model, in which the relationships between files are represented by data values in file records themselves rather than by a physical pointer. So in relational database, the the relation between files are represented by the data values in file records themselves, not by a physical pointers. These are relational databases. Let's take an example. A good example of a relational database system in a digital switching system is a database system that keeps cross references of all directory numbers that are assigned to a line equipment of subscribers. So a good example for relational database is the directory numbers that are assigned to the equipment of subscribers, which is kept as a cross references in a database. When a particular subscriber goes off hook, the line equipment is identified by scanning the program. So whenever a subscriber goes off hook, the line equipment is identified by scanning the program. So by scanning the program, you will come to know, that is by scanning the database, you will come to know which subscriber has gone off the hook. The database is searched to find its associated directory number that identifies all characteristics of the line. So this is a best example for a relational database system. Now let's discuss about the concept of generic program. In the early days of stored program control (SPC) switching system, which we have discussed in the second module, the generic program was more or less the same for most telephone companies. Usually, the generic program contained all programs necessary for the switching system to function. It included all switching software, maintenance software, and specialized office data for the configuration of a central office. So in earlier switching systems, this generic program was more or less common, and it had switching software, maintenance software, and other configurations residing in the same memory, or it was common for all the telephone companies. However, most of the modern digital systems have modular software structure. They usually have a base programs or core programs that control the basic functions of the digital system, switching system. That means they have the base program or core program that controls the basic functions of a digital switching system. They have a modular software architecture. On top of these base programs or the core programs, there are programs that reside different features and special options. So on top of these, there are other programs which reside. In general, the generic programs contain operating systems, common switching software, system maintenance software, and common database softwares for office data and translational data management. So a generic program consists of all of this, and in modern digital switching system, they have a modular software structure. That is what you need to understand from this. In the initial slides, we told that the basic software architecture of a digital switching system consists of three different levels, and we did not discuss in detail about the each level. Now we are going to discuss those levels after discussing the operating system, kernel, database management, and generic programming. Now we are ready to discuss the different level of operations. So let's start with the first level control. Level 1 is the lowest level of control, as you can see that from the figure. This level is usually associated with lines, trunks, or other low level functions, and that is what is shown in the figure. You can see that lines or trunks are connected to level 1 control. The interface controllers (IC), which is represented in the figure, are usually controlled by the microprocessors and may have a small kernel controlling the hardware of first level control. So the interface controller are usually controlled by the microprocessor, and they also have a small kernel which can control the hardware associated with the level 1 control. And you can see that in the circular figure representation, where there is a kernel operating system of level 1 and the hardware structures written in those concentric circles. The level 1 control can also conduct diagnostics of lines and trunks or other peripherals connected to it. So if there are any diagnostics which has to be seen on the lines and trunks, then that is being done at the level 1 control. The level 1 control will then run the diagnostics and forward the results to the central processors. So if there are any line failures or trunk failures, those informations are passed from the level 1 to the central processor as shown in the figure. Sorry. The ICs may have a small operating system of its own. They may also be capable of local recovery. So as you know that interface controllers have a microprocessor, so they have their own operating system and they are capable of local recovery. This means that In case of level 1 failure, level 1 control failure, the level 1 control could recover itself without affecting the entire digital switching system. So the advantage of this level architecture, that if anything happens in the level 1, it can recover itself without affecting the entire digital switching system. So these are the information which you should know at the level 1 of the software architecture. Now let us discuss the software architecture for level 2 control. The intermediate or level 2 controls are usually associated with network controllers that may contain distributed databases, customer data, and service circuit routines. You remember we discussed about distributed databases, the other customer data related information, all these are controlled at the level 2. Obviously, these functions are digital switching architecture dependent. Many switching functions could be assigned at this level of control. So this is one of the main part of the software architecture. The NCPs, that is network control processors, are usually independent of the central processor, and that you can see from the figure. So there are many NCPs or the network control processors which are independent from the central processors. Now, as shown in the figure, the NCPs usually have their own operating system labeled as operating system level 2. So the NCPs have their own operating system and it is referred as level 2 operating systems. This operating system has a kernel that controls the hardware and basic functionalities of the network control processors. At this level of control, usually a resident database system maintains the translational data of subscribers and other software parameters required to control the telephony functions of the NCP. If you remember, while discussing the database, we discussed about this translational data of subscribers and other software parameters. So those operations are controlled by these network control processors at level 2. Consider the function. Let us consider the function of network control processors. Let's say a subscriber goes off hook. The level 1 controller receives an off hook notification from the line module. This we have discussed in the level 1 control. Whenever the subscriber line goes off hook, it intimates to the central processors. Now the level 1 controller requests details of the subscriber such as allowed features and applicable restrictions. So the level 1 doesn't know what kind of features are allowed for the subscriber. That level 1 will be requesting the allowed features and applicable restrictions of those subscribers. Now, the network control processor queries its database for this information and passes it back to the level 1 controller. So, the level 1 requests to the level 2, and the network control processor, which has the database with all these information, will query its database and send the relevant information to the level 1 uh, level 1 control. This type of action required by the network control processor to maintain a subscriber database properly. This database is supposed to be managed and kept up to date with the latest information for each subscriber. So the network control processor having the database should keep its database up to date so that whatever information is requested from the level 1 can be provided from the level 2 to the level 1 line controllers or interface controllers. This is the main operation of level 2 control of software architecture. Now finally let us discuss the level 3 of the software architecture. As you can see from the figure, it consists of central processor. So we need to understand what are the functions of central processor in a digital switching system. The highest or level 3 control is usually associated with the central processor of a digital switching system. Normally, these processors are mainframe type of computers which are highly capable. Usually, the central processor of a digital switching system provides all high level functions. So, what are those high level functions? These high level functions include the management of the database system for office data, high level subscriber data, software patch levels, feature control, and above all, the most important, the system recovery in case of hardware or software failures. The main operating system of a modern digital switching system resides at this level and is labeled as operating system at level 3 as shown in the figure. You can see the concentric circles where all the different processors are explained in the different levels. As mentioned earlier, this operating system operates in real time and is multitasking. That means it can support more than one task at any given point in time. This operating system controls the database management system, switching software, recovery software, and all applications such as features, traffic management system, and operating system interfaces. The most central processors work in an active or standby mode. So they can work in two modes, active mode or standby mode. In this mode, one central processor is always available to go into active mode if the active central processor develops a fault. So why do we require this kind of mode? Because in case if any one of the processor develops some fault, then the other central processor should go into the active mode. So these are the different levels of software architecture which are used in a typical digital switching system. I hope you have understood the overview of the system architecture which is used in any digital switching system. In this module, you have just an overview. We are not going into the details of it because you have already studied these concepts as a separate subject in operating system. In the next class, we will see the different classification of softwares. Thank you for watching.